The Egyptians use special characters for each units, like a 1, 10, 100, like that. So they just place those symbols according to how many of those units are needed for denoting that number. So for example, when we see those kind of symbols all together like that, then we can translate this one in our own number system notation. So for example, this notation is for 1. So we have 5 of them. The next, that is for 10. So we only have 1 10. And that is for 1000. So, and 2 of them. So 2 times 1000. And next one is 100,000. So 5 of them. Sorry, should be like that. And the last one is for 1 million, and 1 of them. So all together, the result must be 1 million and 5,000. Okay, let me just write down this. So it's kind of 2 and 0, 1, 5, right? So the total will be 1,502,015. So please compare these two numbers. When you look at this, it's a little bit kind of difficult in our eyes, right? How many we have, right? But this one is much more clear for us because we are so can used to see this type of number. But that is not the only reason for that, because in Egyptian number system, there is no position value. So which means you can write this one in any order, but we still get the same result. So you can put this notation in front, at the end, in the middle. Doesn't matter because that symbol is matching with specific number. But in our number system, it depending on what number is used where, right? So if even we use same number, the position has its own value or weight on that specific position, right? So it means totally different. But after we get used to it, it's more clear, right? And another thing is very easy to calculate, okay? Like we have this addition, subtraction, and all the stuff, right? So big difference between this Egyptian number system and our number system is positional number system because each position has its own weight, and the Egyptian number system is not a positional number system. Okay, let's just do more time in the reverse way. Okay, how can we translate this number with Egyptian number symbols, right? Numeric symbols. So the first one is 20 million. Now instead of write down this symbol 20 times, because there is a symbol for 10 million, right? So for 20 million, we only need 2 symbols, like, right? The next one is 130,000. So we have a symbol for 100 and 1,000, right? So we need 100,000 and 3. Oh, that's a 30, right? Sorry, 130. So we have 3 of these symbols to replacing 30,000, right? So we have to put 3 of these. And next one is 695. So 600. Now for that we need 6 of them. So if it in the worst scenario is like for 90 here, we need 9 of these symbols, right? So placing 9 in a row takes a lot of space. So if it's more than 5, we can use 2 lines. But there's no rule such thing. So if you want, you can make it 3 lines. Okay? Doesn't matter. So for example, for 600, you can write down this symbol 6 times in that row, right? Like that. But how about just only 3 for each line? But that's 600. And for 90, we need 9 of these. So you can put 5 at the first and 4 at the second, or how about just place like this? Still same thing. And the last one is 5. So 1, 2, 3, 4, 5. So key point is we don't need to keep the order. So instead of placing this 20 million, we can put that one over here, but still we get the same result, right? And even how many rows we can use, no rules about it, right? So same thing, you can just put 6 of these symbols like that, right? Instead of that. Okay. So that's the maybe good part of using non-positional number system, okay? Because we don't care about the position. But the problem is the operation of numbers a headache, right? So just they don't have used this kind of plus signs, but if you just have this one with all that stuff, right, like that, right? So can you do that? Yes, of course, but you have to think, okay, which symbol is similar to, same symbols for each other, something like that. So then you have to count and like that, right? So this is a simple addition, but just imagine like a multiplication. Now then you're in big trouble, right? So we are not talking about the positional number system yet, which we will cover in later chapter, but just to try to compare what's the good thing about using positional number system, right? Okay, for next practice, please do, and let me do example 4. Is the Egyptian number system a positional number system? It's not, because simply this one and that's exactly same number. I should choose some different one because there's no, okay, so let me just use this way. So according to that symbols, I just write down 1 and 2 tens, right, in different order, but altogether the meaning is 21, right? But if I write down 1 2 and 2 1, then in our number system we are not talking about same number, because the position is very important. So one number is used at the units and tens and 100ths position like that, right? So the answer should be no. The positions of the symbol doesn't affect the value of the number, right? That's going to be the answer. Okay, next one is a Greek number system. In this system, the Greeks actually invented many more symbols for each unit values and for each tens and 100ths. So when you compare the previous Egyptian number numeric symbols and Greek ones, they have more symbols, but it's much easier to write down the entire number. So like just imagine you write down 900. In Greeks, all you need is this last symbol, right? And when you write down this one, you're only talking about the 900. Now you try to do it with the Egyptian numeric symbols, then you have to write down 9 of the same symbols, right, for 100, right? So this is much easier. And another thing here is, it's not positional number system yet, okay? But they try to keep the larger number on the left side, okay? So starting with the largest power of tens on the left and write down next one and next one like that, right? So for example, for 804, we want to write down 800 first, which is omega, and 4 is a delta, right? So omega delta is the one. So they didn't write down delta omega. Still, because it's not a positional number system, you can understand it, right? Because it's 4 and 800. So if you're just adding them, it's going to be 804, right? So that's the reason why we say the Greek number system is not positional number system yet, but they just want to write down the largest one first. Okay? So in that manner, how about 462? So 400 is epsilon, right? So like that. And 60 is psi. Okay, time. And 2 is beta. So that's it. Then how about this one? Okay? What is exact that value means? So what is tau? Is same as 300. And lambda is here is 30, right? So that should be 313. Okay? So just to make any number and using these notations, you're just asking each other, right? With your classmates or with your kids, right? It's going to be a simple way to translate. Okay? Okay, there are several rules in Greek number systems because they invent those kind of notations, symbols, but not for the big number, right? So instead of making new symbols, they just try to invent some unit systems, right? So it's kind of closer to our positional number system now we are using, but okay, it's not really that much, but it's much more clever than the Egyptian numeric system. So the first rule is we can put they put some accent mark in front of certain symbols. Then it means like you can say it's a comma or apostrophe, okay, whatever. Then it means you have to multiply 1000 to that. Okay? So that accent beta means beta for 2, right? But we have to put multiply 1000 for that. So eventually that is same as 2000. Okay? Then accent mark sometimes can be omitted if that context is clear that what we are talking about, right? So it's like delta, sigma, lambda, delta, okay? So delta is 4, and sigma is 2, lambda is 3, and delta is 4. So if they want just adding all this, right, all together, then it should be 13. Then for 13, 10 is iota and 3 is gamma. So it should be iota and gamma should be enough, right? Why they use this kind of longer and more symbol notation? Then it shouldn't be like a simple addition like this. Then they accept what? Oh, kind of by positional, okay? Wait, so the first delta is not simple 4, but is with something, right? Like that. So it's technically, it can be same as 4234. So if it's clear enough, they don't need to put that information, right? Okay, so altogether, it's showing us how we use, okay, those symbols and that accent mark to present a bigger number. Okay? And the letter M, the capital, looks like capital M, placing next or below to any symbol or symbols, which means we want to multiply that symbol value by 10,000. So delta M or delta sub M is delta times 10,000. Okay, and delta is 4, so 4 times 10,000, so it should be 40,000 for that. Okay? Or sometimes rho B M or rho B sub M, like 15, okay? So 1,500, right? And times, I mean 150 times 10,000, right? So it becomes 1,500,000. Okay? So it's much more clever, right? They don't need to invent new symbol for 1 million or 500,000 or even it's 100,000. Instead, they kind of developing a symbol for multiplying certain big number, right? 1,000, 10,000, something like that. Okay? And because of that, double M means, right? It's easier, okay, to get that concept. Okay, if the capital M working like that, then how about make it double? Then is 10,000 times 10,000. Okay, then much big number. Okay. Okay, so when you look at this one, what is going to be the value for that number? Okay. First of all, beta is for number 2, right? Okay, so that is 2. But after that, we have double M. Okay, so we can put like 10,000 square, right? Like that way. And of course, it's all together beta with M and M, right? Okay. One we can think is, you might think, okay, how do you know this double M is for beta? How about the next ones, right? It might possible. So instead of that, it's going to beta and what? M, M, and maybe sigma or whatever like that, right? But in that case, what is the meaning of beta in there? It's not that clear, right? So that's why we can assume, oh, whatever this M is used and the previous symbol is kind of separated and kind of alone, right? Stay alone, then we should think in that way, right? So that's how we can do this. And after that, sigma, and by that, pi and M, right? So that's the next group, right? Okay, so what is sigma and pi? Sigma is for 200, right? And pi is 80. So sigma pi should be 280 only. But because of that M, this one is same as 280 times 10,000, right? So that is actually 2,800,000, right? There. And the next one, I'm sorry about this small, but it's kind of that accent mark and gamma and alpha, right? So gamma means 3 and alpha means just 1. And this accent is for the very next one only. So that is 3 times, the accent means multiply by 1,000, right? And plus 1, right? So maybe you can better to think like this, right? So that is same as 3,000 and that is 1. So the first number is actually 2 times, we need 1, 2, 3, 4, 5, 6, 7, 8, right? That much big number. So it's going to be 200 million plus the next numbers, right? So all together, that symbol or that whole kind of symbols is equal to 202,803,001, right? We need one more like that, right? Just be careful when you're adding those steps. So for next practice, please do and checking together. So that once again, that accent mark is for the very next number, and most likely M is for the previous ones. Okay. So in this case, that translation is wrong, right? There's a slight difference. So please redo it this one again, or checking with this one. Okay. Either way, then you can find what's wrong about this one. Okay.